So I'm getting ready to do several examples of finding the area under the normal curve, and then some that are the opposite. You find values that have certain areas, and I'm going to use normal CDF and inverse norm on the calculators. I'm also going to use the z-table to show you how to do that if you had to. So the summary here, when you're doing these normal distribution questions, they all involve in some way the area under the normal distribution. And you can either convert to z-scores and use tables if you have to, or if you have software that can do it much more quicker, we can do that. And the TI-83s and 84s have commands called normal CDF, normal cumulative density function, and then the inverse norm, which is the opposite that I'll show you on an example. So I'm going to do 3 examples right now of using inverse norm. I want to show you the different types of inequalities you could run into in terms of less than, greater than, or in between 2 values. So I'm going to do 3 similar examples looking at these Angus steer. And I left my weights off, the units off. These should be pounds, but the mean weight of Angus steer is 1,152 pounds with a standard deviation of 84 pounds. What percent of steer weigh over 1,200 pounds? Assume it's a normal distribution. And we're going to solve it both with z-scores and with normal CDF. So first of all, though, we should think about the picture. We should at least think about this, but I would say draw the picture. Draw a normal distribution, make a sketch of what you're trying to find. That'll make it much easier to do the rest of the problem. So we have a normal distribution centered at a mean of 1152, so 1200 somewhere in front of that. And we want to find the percent of steer that weigh over 1200, so that would be to the right of it in the picture, the area shaded above the 1200 or to the right of the 1200 between the graph and the axis. That's how we use the density function. So we could answer that question if we could find the area right there that's shaded. So I'm going to do that first with z-scores. If I did z-scores, I would have to take the 1200 and convert it. So remember, the formula for the z-score is x minus mu over sigma. You subtract the mean and divide by the standard deviation. So we take the x value of 1200, the individual weight of 1200, subtract the mean and divide by the standard deviation, you wind up with 0.57. Okay. Again, the interpretation there is that a weight of 1200 would be 0.57, or a little more than a half of a standard deviation above the mean of 1152. And then, if we wanted to find that area, let's see, I would have to use symmetry on my table. So if I want to find, I'm going to write in terms of probability, the probability that if I randomly selected a steer, that the weight would be greater than 1200, that's the same as the probability that its z-score is greater than 0.57. I'm going to use the symmetry of the table, since the table is set up for less than problems, to do the probability that z is less than negative 0.57. So if I look in my table, I've just chopped off the part that I need here, but I go to negative 0.5, go over to the column for 7, and I get 0.2843. So let's see, I always answer the question the way it asks. It asks for percent, so that'd be about 28%. Okay. 0.2843 is a proportion, 28% if we convert over to a percent and do the nearest percent. Okay, now I'm going to use normal CDF, okay, which I've already done before here. I was working this problem before the video, but you do second and the variables button and choose number 2 to do the normal CDF. And then I've already got the numbers entered in, but if you get the menu, it tells you the order. If you don't get the menu, you do the lower, comma, upper, comma, mu, comma, sigma. I'll show you on the screen here in a minute. But when you get the menu, it reminds you of the order. You have to do the lower bound, upper bound, mu, and sigma. So the lower bound, if we look at what we're doing, the smallest number, the leftmost number for our shaded area is 1200. And then we're going off to infinity, but we can't put infinity in the calculator, so what we use instead is a very large number, and we can do 1e99. That's scientific notation. That would be a 1 times 10 to the 99th, which is 1 and 99 zeros, a huge, huge number. And the e is above the comma button. So if I want to do that, I do 1, second, and the comma button, and then 99, 1e99. So that's a huge number. We're going to go from 1200 to a huge number that's approximating infinity for us. And then you do the mean and the standard deviation for the distribution you're looking at, which is 1152 and 84 for this problem. And when I type paste, it'll put it on the home screen, and those of you that didn't get the menu, this is what it would have to look like for you from the beginning. You have normal CDF, and then you have to type the numbers. So you have 1200, lower bound, comma, upper bound, comma, mean, standard deviation. Enter. And if we carry it out to enough decimal places, the calculator procedure is actually a little more accurate than the table because we didn't have to round. So we don't match when we get out to the thousandths place, but it's about 28%. We got 0.2838, whereas in the table we got 0.2843.